Hey guys, how are you guys doing? Oh, come on, we can do better than that. Come on. All right, thank you. Hi guys, so today we're gonna talk a little bit about Kubernetes. We're gonna talk about observability policies, practices, kind of what we're seeing in the industry. And we're also gonna talk a little bit about security. So my name is, you need to not touch the microphone, we're gonna do that. My name is Marky Doobie. I'm actually a principal solution engineer with Dynatrace. And I've been with the company about 11, actually almost 12 years now. So almost a dozen years. I actually started out completely thinking I was going to be a developer, went to college, got my computer science degree, got my master's in computer science, and then I realized I'm gonna go crazy if I have to sit in a room by myself all day. So I'm gonna go talk to people. And I found the company called Dynatrace, and that was just match made in heaven. So I've been with them since, just working on different enterprise customers, working in their environments, seeing what they're doing, checking out their policies, figuring out what works, what doesn't, and kind of carrying that forward to other groups as well. I have Jason with me today as well.
Yeah, hi everyone, Jason Ostrowski, also a principal solutions engineer. And I actually have a pretty similar story to you. Computer engineering degree, and then could not sit in a lab all day. I had to move. So I spent the last 9 years with Dynatrace, helping organizations on their observability strategies, and I'm super excited about enabling innovation through automation and helping improve customer experiences and all those sorts of things. So part of our role with Dynatrace is actually being the conduit between our customers and the industry trends and our lab and our R&D organization. So what's cool about that is we actually get to bring all the use cases and challenges and everything that our customers are seeing back to our lab and then help influence the product, make it better, solve your questions, solve your challenges. So yeah, afterwards, come hang out with us. Come see us at booth 606. It's always cool to hear what you guys are running into.
All right, so as I mentioned today, we're gonna talk a little bit about Kubernetes. So we're gonna break this up into kind of 4 different topics. We first really wanna talk about what we run into with Kubernetes, right? And one of the things that happens quite often is you run into silos. And you run into silos in every organization, but then when you add in a technology stack that adds its own silos on top of it, it kind of adds a little bit more complexity to that. So we wanna talk a little bit about the importance of making sure you have your data there and in context. And then we're also gonna take a look at, okay, now we have the data, what do we do with it, right? So we're gonna talk about AI and some of the options that we have for utilizing that to kind of carry that field forward. SLOs are a huge topic in every company that you go to and talk to, right? We've gotta make sure we're meeting those contracts, we gotta make sure we're meeting those goals. So that's something we're gonna jump into as well and kind of talk about how we can automate the process of enabling those, of utilizing those, because nobody wants to be able to sit down and have to do this manually, right? Everybody knows every company has this side pile of Excel spreadsheets somewhere, right? We gotta make sure that we can kind of move that. Excel is awesome. I built half my career on it. I love it. However, right, we wanna make sure we can automate that as much as possible. And then we're gonna talk about security as well as we go forward. So, as we mentioned, Jason and I work for Dynatrace. So I want to give you just a little bit of a rundown of who Dynatrace is, right, before we get started. So Dynatrace has actually been in the observability space for upwards of 15 years. We initially started just purely distributed tracing, right? That was what we did. And then we've evolved over time, right, into some of these more complex environments and things like the cloud space and building out, right, what that looks like. Because we've been in the space for so long and because of the customers that we work with, we've actually been ranked by multiple community organizations as one of the top performers in the observability space. In fact, we've actually been in the Gartner Magic Quadrant for APM or observability for about 13 years. This past year being the absolute top of that space. So this is something that we really want to focus on. We really want to make sure that organizations are taking advantage of from a best practice standpoint. So again, just a very quick overview of the Dynatrace platform itself. So Dynatrace is an observability platform. So we focus on observability and we focus on analytics. Those are kind of the two primary use cases that we look at. And when we talk about observability, we talk about both from an application performance standpoint, from an infrastructure standpoint, because infrastructure is cost and its impact to those applications. We also focus on things like security. We focus on business metrics and business KPIs. So all of that actually comes together into this Dynatrace platform. And you'll see a few pieces as we kind of go through today as well, just through a couple through examples. Some of the core components of the Dynatrace platform that we have built our system on are things like AI. So we have the Davis AI engine, which is actually purpose-built for observability, right, and for that space. We also utilize some technology such as the One Agent. One Agent allows us to actually automatically discover what is running within your environment, automatically instrument that so you get code level visibility, and provide that information back to a centralized platform so you can analyze that in context. Now, just because we have an agent doesn't mean you have to use that. We do accept things like OpenTelemetry spans, logs. Those are things that we're very active in as well, and we're actually one of the major contributors to that space because we think it's important to make sure that companies have those type of practices in place as well. We also partner very strongly with cloud providers, in particular AWS, and we partner with them because they are one of those major contributors, and we run most of our systems there as well. You can see here we've recognized by AWS across the board multiple different certifications. In fact, I'm going to add one more to this list, which is not on the slide, because it was just announced today. We officially today were recognized as AWS security competency as well. So that is something, again, if you want a little bit more detail on that, you want to dig into that, we do have our security specialist here at reInvent in booth 606 if you want to stop by after the session. Now let's get into what we're actually here to talk about, right? That was enough about Dynatrace. Let's talk about Kubernetes. So Kubernetes has been growing year over year, right, within the environment, just within the industry as a whole. And one of the things that we found, and this is actually from a survey done by CNCF, is this is actually growing exponentially in the cloud space as well. Because companies are utilizing Kubernetes to be more flexible, to be more agile with their customers, to be able to meet those customer demands. But at the same time, because of the complexity that can come along with this, more and more companies are opting to move this to cloud-based infrastructure. Things like EKS, things like Bottle Rocket, these are things that are becoming more and more prevalent across the board. Now, with the ease of getting rid of that infrastructure, now you also have the concerns of, but what's going on? It's not mine, I can't see it anymore. And that's where observability really comes into play. That's where we really want to make sure we focus. And speaking of complexity, right, when you're talking about Kubernetes environment, these are built to be highly dynamic, highly changing. But because of that, we run into the scenario of, okay, what is my actual architecture diagram? Where do my systems actually hit? What are my different endpoints that are open? Where do I have to watch? What logs do I need to pull in? What's the infrastructure component? What's the piece running in between? All of those different pieces come into play, and it just adds more and more levels on top of what we actually need to pay attention to. Which is why we need to make sure that when we're going into this, we have a plan for how do we want to track, how do we want to observe, how do we want to monitor these systems to make sure that our business actually does stay up and running. We want to make sure we're looking at the infrastructure, we want to make sure we're looking at the applications, and we want to make sure that it's all in context. And that's one of the key pieces there as well.
Thanks. So how do we simplify that complexity and understand the performance of our applications and the underlying platforms that they're running on? I think the best way to do this is through observability data in context. It really provides the foundation for improving our applications, improving our end user experiences. Because there's a lot of questions that you want to ask if you ask applications, like what's utilization like? Are we meeting the end goals of our application? Are we meeting our SLOs? What's performance like? And really all these answers come from observability data. Now, typically people are thinking of observability kind of as just metrics, logs, and traces, and certainly that's important, but it's more about building a whole platform around that that's important to be able to get answers from that data. Any observability solution has three kind of basic parts. One is access, right? How are we actually getting that data? It could be through open source solutions or open telemetry, Prometheus. It could be the one agent that Marky had mentioned. Could be environment native, right? So CloudWatch, X-Ray. Then we have to aggregate that data. And where we're aggregating it is something that has to be super scalable, because we all know that data is growing fast, right? It just keeps on growing. More and more data types, more and more ingest from everything. So it has to be super scalable. All that stuff has to be related in some way, because it's really important to know the horizontal topologies, like web server, app server, database, as well as the vertical topologies, right? What is it running on? You know, which process, which cluster, stuff like that. It also has to be expandable, because as we start looking at this data, it can be used for so many different purposes, right? My same trace or my same log could be used for business use cases. It could be used for, you know, performance use cases, security use cases, right? So it has to be expandable for all those different ones.
I think that's a really important piece there as well, just because when you think about it, a lot of times we think of tracing as, okay, how long did this take, or right, were there errors? And we kind of stop there, especially from a technology standpoint. But if you give that same trace to a different user, right, to a business analyst, he's going to want completely different information from that. So those are the kind of things we really want to make sure we're kind of focusing on.
Exactly, right? Make it expandable and make it available, right, to ask those questions of the data. And that's kind of getting to my next point, right? Being able to do analytics on top of it, right? Be able to detect anomalies when we do have problems, stuff that's outside the norm. Comparing our performance to, you know, known operating standards or models, building up SLOs and SLAs and tracking against how we're doing against those, and building baselines, right? Understanding what normal is, and then when things deviate from the norm, being able to alert on that and find out why. But I think it's also important not just to get answers from, or to ask questions of this data, but really to be able to get answers and to be able to automate from that. Because when an outage occurs, it's super important to know, like, how many users are impacted? How bad is it really, right? What's the root cause of it? Who's the owner? Who can actually fix this, and what is the fix? And then be able to drive automation off of it, right? So not just, you know that there's a problem, I know how to fix it, but how can we automatically fix it? Can we, you know, fix it before it becomes a massive problem? Do things like predictive analytics, and then drive automation from it. So from a performance perspective, reliability perspective, you know, roll back bad deployments, scale up, things like that. And even be able to do cost optimization, right? When things are underutilized, scale that stuff back. So with all that observability data, right, what should we be looking at from performance perspective, from an optimization perspective on our applications? So it's critical to have visibility into each layer, right? Starting at the application, through the workload, the namespace, the node, all the way down to the cluster, because there's so many, you know, application decisions that impact the platform utilization. And then also, if the platform isn't running correctly or is undersized, right, the applications won't be able to perform well. They won't be highly available. They won't be able to scale as needed to keep that positive user experience. So we kind of have to look at all this stuff holistically. At the application layer, we're typically looking at things like response time and error rate, throughput, kind of a lot of those golden signals from both the overall service performance, but also on key individual transactions. The holistic service is really good if you're kind of looking at dependencies, or, you know, are we meeting our goals? But then, you know, you have to look at the individual key transactions as well, because if on average everything's performing well, but something that impacts logins or checkouts or key conversions in your applications, if those aren't running well, then, like, we've got a big problem, right? So it's not just the overall performance, but also our individual key transactions. And you want to hide in the averages when those key transactions are so critical. I think it's also super important to understand how your service plays in with all the other services, right? Because everything has so many different dependencies, and we've broken everything up so small that, you know, an issue on your service could cause a cascading effect across other services, or if, say someone says, hey, Marky, your authentication service is super slow, but like your downstream dependencies is actually the problem, like you kind of have to know how that stuff interacts.
How many people in this room have been in a war room like that? Come on. Everybody has, right? That's the scenario that we want to try to avoid.
Exactly, yeah. When you do have slowdowns, really important to get distributed tracing with code level depth if possible, right? Because that's where you can figure out where those issues are really occurring and see if it's an N+1 query problem, which method, which exception, which span is it. Having that deep visibility helps you actually fix those issues really fast. And having unified observability, having all of that data in context, right? Your metrics, your logs, your traces, your topology information, the user experience, all of that stuff that helps expedite and troubleshooting and reduce MTTR significantly. One thing I'm a big proponent of is enriching your logs with trace data and with topology information. Because this is basically adding in like a trace ID or a span ID or any topology information, the app, the namespace, pod, whatever it is, to the actual logs that are written from those. Because when you're troubleshooting a problem, it's really difficult to understand, like, what's a symptomatic log? Like, what's actually the problem? Is it in this time frame? You're like fumbling around with a bunch of different filters and stuff and queries. But if you can go and say, hey, I know this transaction failed. Let me see the exact log that was written from that failed transaction. Like, that simplifies the process significantly. Makes it super easy.
Yeah, no, I think that's the key piece is context, right? When we talk about observability data, when we talk about pulling in these different components, you got to make sure you have the context around them so that you can link those pieces together. Because if you just know, okay, my CPU is high over here, or yeah, we're seeing errors in the logs, but we don't actually know which customer was impacted by those, right? There's no value in that.
Yeah.
Those are the things we got to make sure we're piecing together. So you have to have the data all together in the same context.
Yep, absolutely. And that enrichment that I was mentioning, it's something that you can do automatically with Dynatrace, but most observability solutions have a way of doing this. You can do it even just manually by just adding, manually doing enrichment to add like the trace IDs or span IDs to your logs as well.
Yeah, I think we ran into several customers or prospects who became customers who actually told us they were doing this themselves manually. And they said, well, we have this correlation ID, can you use it? It's like, well, we build our own, but people have had to find solutions for this because they haven't been able to piece together that information. So it's something that can easily be built into applications, especially with things like OpenTelemetry. They make it super easy and super straightforward to do that with.
Yep. I also am a big proponent of kind of shifting from the mindset of just like, is my individual service available and running, to how does my service really impact performance of the end user and of business performance. It really helps us, kind of can take us a long way in terms of understanding, our actual business performance, meeting our business goals. How well is performance for our end users? Are we meeting our end goals? Maybe do we have to change some functionality in our application to better, improve customer experience? So kind of taking a step back and thinking at it from the user perspective is really helpful. Gives us that business insight because, like, at the end of the day, our applications are built to serve a business function. So it might be good to make sure that our end users are having good experiences.
Even if your end users are internal.
Yes.
It's still a business need.
Yep.
It's still somebody you got to pay attention to.
Yeah. Again, kind of with context, right? Looking at applications in the context of the infrastructure they run on helps us solve issues a lot faster because there's a lot of different decisions that we can make that impact the platform utilization. And if the platform isn't running correctly or is undersized, the applications won't be able to perform well. They won't be highly available. They won't scale as needed. And we can even drive automation, like scaling things up, rolling back deployments, stuff like that, when we have that data in context. Going a little bit deeper down, right, at the workload level, we need to understand if infrastructure is impacting pod and workload health, right? Are their pods restarting? Are things not ready? Are there pending pods? And then being able to drill down, understand why, right? Look at the performance metrics, look at the events. If there's out of memory kills, if there's evictions, like knowing when those issues are happening.
And a lot of times what we run into with these scenarios is you have maybe 1 or 2 people in your organization who are the Kubernetes expert, and they will go down in and they'll dig into logs and they'll find these details. But if they're not working that day, or they're working on another system at the same time, you got to make sure you have a system that can surface this stuff for you. Yep. So you have the ability to pull this in and make it actually something that's consumable for the rest of the organization as well. Yep. It's about kind of pulling those together.
Yep, giving everyone access to that data and then bubbling up. Yeah.
Breaking down the silos.
Yeah, exactly. At the namespace level, check on resource utilization, if there's any saturation issues, track the logs and events associated with that, if we're hitting any quota saturation issues in CPU memory, things like that. And on the node level, is everything healthy and up and running? Are there any issues from saturation from that perspective? Too many pods running on a node? And finally, at the cluster level, how is health and utilization? Is there anything that's stuck, pending due to resource utilization?
Right, so Jason was just talking about all of those different levels that we need to be paying attention to. We need to be paying attention to the actual applications themselves, to the workloads, to the pods, to the underlying applications themselves, to the cluster, all of those individual details. But now that we have it, what do we do with that data? Because again, we still don't want to be stuck in that scenario of somebody having to go through and manually analyze that data, or manually set those thresholds. So when we come up with something like this, where we have this list of these are the things that we should be paying attention to, do we have to now go through and actually set up our own manual checks and manual pieces to go through? Yeah, these are good things to base off of. I need to know what's going on here. But I also don't have that much time in the day to sit down and actually go through this myself. And I know it's probably not helping the rest of my business if that's what I'm trying to do. So taking these individual pieces, looking at the infrastructure, looking at the node health, looking at my application response time, and providing that to a system that can use AI to actually analyze that information, that's really where some of this comes into play. And there's a lot of different systems that can be used for this. Again, I mentioned Dynatrace has the Davis AI engine. It's one of the things that we look at is this data in context and looking at things like dependencies, looking at things like what, for this particular transaction, where was that running? How is this being impacted? Not just these things are happening at the same time, but we want to make sure we're looking at this from a causal perspective, which is why that context is so important. So when Jason talks about things like the trace ID and the span ID and those key details in the logs, that's why that information is so critical, to be able to link together those different components, those different systems, so that we can actually go through and be able to map these individual pieces together and have that context, because then you can take something like an AI and it can do that analysis for you. It can look for things like anomalies within your environment. Maybe I don't go in and set my hard and fast response time threshold. Maybe I don't go in and set my CPU threshold, especially on a Kubernetes cluster, because holy cow, that would be insane to do, Trying to go through and set that up, especially when those clusters are auto-scaling, when the pods are changing on a daily, if not hourly, if not minute basis. This is ways that we now want to be able to go through and track. So instead of looking at those hard thresholds, we look for anomalies. What's changed? And when that changed, what else happened? And being able to look at that holistically across the board.
What's also cool, I want to just add in one piece there, is if you can add more events in there as well, from like a deployment perspective or configuration change, then you get another layer of context, Because it's not just, hey, now I saw a response time spike, but there was a deployment change that happened right before that response time spiked. Like, maybe we should just roll that thing back, So bringing in that additional layer of data to be able to, track that stuff and understand the impact of it.
Yeah, it's one of the things I always tell the groups that I work with is, yes, we can pay attention to the application. We can do as much as we possibly can from a technology standpoint, but we also need to understand the business. What changed on the business? Maybe it wasn't a deployment. Maybe it was the marketing team pushed out a new campaign today and our traffic tripled.
Yep.
Right? That's something that's important business context that can come into play. And having those events and those details available with an observability solution and using AI to be able to analyze those are things you can actually pull together.
Yep. So like all the awesome stuff that Marky just mentioned around causal AI and baselining, anomaly detection, that's perfect for production workloads. Define exactly what the root cause is, getting us to precise root cause, finding when problems occur. But what about preventing these problems before they even happen, right? And what about tying application health to business processes? That's where SLOs can really come into play here. So SLOs, service level objectives, essentially they're the target goal of quality or reliability for a specific service. And over the last few years, we're seeing that these become an incredibly useful tool for release decision making, for business process decision making, risk release assessment, stuff like that. So essentially, right, if my team's not meeting my SLOs, my goal of quality of my service, then we may have a freeze on new changes. We may have to focus on beefing up reliability. But it doesn't necessarily have to be like punishment either, right? If we're meeting all of our SLOs, and we've got like super solid service, performance is really good, then we can focus more on innovating and pushing out new features and continuing to release. So it just helps us understand like how are we running from a reliability and performance perspective? Should we focus more on new features, or should we be focusing more on reliability?
Yeah, it's really a risk assessment for the business. Which direction do we need to go this month, and how do we change that focus?
Exactly, and because these are business critical services, it becomes a good common language. Everyone's talking about our login service, our checkout, things like that, and it becomes kind of the common language for business owners, for DevOps, for SREs to say, hey, like how good are we doing, right? For a specific business service. So, some common SLIs and SLOs, because everyone kind of asks me like, what should I start with? And it really kind of depends on your role and the business function that your service supports. So if you're looking at something that's an end user facing application or service, think about availability, conversion rate, engagement. Are users actually engaged on your application? 4 golden signals from the SRE framework, that's always good, like latency, errors, traffic saturation. If you've got like an internal service-centric service view, maybe look at utilization, saturation, errors, or workloads, looking at like rate, error, duration. And tracking and analyzing these SLOs according to their business function is a great place to start. Starts those conversations and get everyone's on the same page of like, how good is the quality of our services? Should we be focusing more on releases or reliability?
Yeah, you get past our app is slow or customers are complaining, and you get down to the detail of how is this actually impacting us directly, right? How are things like logins impacting the rest of our business, right? Those are things you can really get down to and track.
Yep. But we can't do this manually. Again, with the automation thing, right? Like as we've modernized our apps, right? The complexity, the dynamic nature, like is just the scale, right? It's just way too much to be manually analyzing our SLOs. And it's best practice to leverage automation to check the quality of our services around those SLOs to ensure flawless delivery and great customer experiences. And so this is where automation really comes into play. From a couple different angles, right? From kind of the non-prod, making sure that we're only pushing up safe and high-performant releases into production. We can do those SLO checks, right, in those lower environments, and then automate the evaluation of those. From like an SRE perspective or a reliability perspective, we can also do those SLO validations or release evaluations after a new release has happened, right? So I push out a new release, run that SLO check, make sure that it's performing against my standards. And if I'm doing progressive delivery or canary releases, if it's good, right, keep pushing more traffic to it and keep rolling out. If it's bad, roll that stuff back. So kind of in that non-prod DevOps use case, right, we want to evaluate our SLOs as part of our CI/CD pipeline. So kind of how this works is from your CI/CD tool, like it could be anything, right? You deploy a new artifact, and you trigger a performance test or a load test, just something to give it traffic to see what the actual performance is like. And then you send a test or a deployment notification to your observability tool to then know that there was actually an event that took place there and do an evaluation. You evaluate the performance of that and then pass those results back to your CI/CD pipeline tool, which then can automatically approve that, right, and keep rolling it up into the next production change, anything like that, or halt it, right, and say, hey, this isn't good, right? Can't keep on moving forward with this release. You've got to go fix the actual performance and quality of it, and then deep dive into like the diagnostics, into distributed traces, into code profiling, all that type of stuff to fix it for the next go round.
Right, but that's something you do the next day, right? Not at 2 o'clock in the morning when the release goes out and you have to wake everybody up. You want to automate that process. So, okay, pushed a bad build, happens kind of across the board. Let's roll it back. Let's automate that rollback. Let's go back to a safe state. Tomorrow, when everybody has actually gotten sleep and they're awake and they're in the office, then we're going to dive into the traces. Then we're going to dive into the context and the details underneath to really determine where that is.
Yep. It's also really helpful to be able to track your release evaluation over time to understand, like, are we getting better? Like, is our success rate getting better? Are we getting worse? And maybe which SLOs are failing. Maybe we need to rethink what we're actually tracking, or maybe we need to set different standards for some of those things. And don't just take my word for it. We actually worked with a financial services institution that it took them 32 hours from the end of a test to approving or rejecting that test or that release. And it was painful, right? They had to go through and they actually pulled down results manually. They punched it into an Excel spreadsheet, and then they were like looking at it and running macros and comparing it to previous ones to see if it was good or not. And then manually going and approving it and saying like, hey, this is good or this is bad. This is painful. So because we can do this all automated, I mean, like even just simple scripts could do this too, right? To go check the quality and then push the good ones up. This manual evaluation, that's kind of ripe for automation.
And that's the key piece there too, is it doesn't have to be a specific tool, right? There's a lot out there that do that. But one of the things you want to make sure you are doing is having those checks in place and having those built into your pipelines so that you are not, right, the person going in and doing that check. Make sure that there's a system there in place to be able to do that for you.
Yep. Talking about the reliability aspect of this one, like once we're actually running this stuff in production, wanted to walk through a scenario where Dan, he's got this new feature he wants to deploy, right? And he's really only looking at his change and his service, not all the other downstream dependencies. And since we started to break up our app into microservices, there's a ton of downstream dependencies. At the same time, Omar goes and deploys a change, not realizing that it may impact Dan's service, not even knowing that Dan's doing a change at that same time. And we all know this could cause catastrophic failure. So how can you go through and check that your service is working after the change, and regardless of any other changes that may have occurred during that window?
One thing to think about too is you think about those different microservices. That's what Kubernetes is built for, right? that's that environment. So that scenario there that Jason was talking about, those two different developers pushing out two different updates, they're both running on the same K8s cluster, or maybe they're running on 3 different K8s clusters. Right? It doesn't matter, but those systems talk to each other. And you need to make sure that when you're looking at things like observability and tracking, you're not focusing on what's going on here, right, in this application or in this cluster, but you got to look at it holistically. You got to make sure you're paying attention to what's going on across the board, because more and more of our applications that are built cloud native, that are built to run on Kubernetes environments, are going to look like this. They're going to have little tiny pieces, right? This does the login authentication. That's all it does, right? We break those pieces up so that we can iterate faster, so we can add better performance, so we can break those in, but that also means architecture diagrams start to get more and more complex. So having a system that can analyze this for you is really the key piece.
Absolutely. And that's exactly what we can do, right? We can go through and validate that our service is running well after those changes have been made, make sure that our key transactions are running well, regardless of any other dependencies, right? And if something doesn't work correctly, we've got that context, we've got distributed tracing, we've got all those tools to go figure out if it was another change that made that impact, and actually automatically roll that stuff back.
So in tracking that and in looking at all of those different pieces that Jason was just talking about, one of the key things that we also want to think about as well is not just what if somebody pushes out a build, right, that maybe slows something down or causes some errors. What if somebody pushes out a build that's got a vulnerability in it? They added a new third-party library, it's really popular, everybody's using it, they don't think much of it, and now all of a sudden you've got vulnerabilities in your application as well. Same thing is happening. That vulnerability now impacts not just that application, but everything across your stack. And those are things we really want to make sure we're paying attention to as well. So one of the things that we did within Dynatrace is we wanted to make sure, again, that we were actually talking to the industry leaders, talking to community members, and seeing what is actually on your top of mind, right? What keeps you guys up at night? And when we went through and we talked to the CISOs, a lot of our different customers, and even non-customers as well, one of the things that they continually came back with was they were constantly worried about these vulnerabilities getting leaked into production. Right? It's just one of those things that's always on the top of their mind. And the biggest thing that they worried about there was because we have this constant role of getting releases out. We have to make sure we have that functionality there. Our customers are waiting for this feature. We can't hold this release anymore. One of the things that constantly comes up is putting security in the process stops the process, right? It slows everything down. So Jason was talking about manual performance tracking that the group was doing. Think about trying to do that from a security perspective. Right? That just adds a layer of complexity on top of it. So when you have those security checks and those things in place, it can really slow down that entire pipeline and that entire release cycle. And businesses can't afford that.
And a lot of the times you're making those decisions like, hey, so how many vulnerabilities do we have? And like, do we have time to fix this? Well, we have to get this new release out there. And so it's kind of this internal struggle that you have, right? Do we take more time to go fix this stuff? Or do we keep on releasing? And what people are kind of scared about is that like, we're trying to move so quickly, we don't have time to scan and fix these vulnerabilities. Like, what are we leaving ourselves exposed to?
Yeah, and that's really it. And I mean, this is not a small issue across the board. You see things like any average Java process, right? Minimum 50 vulnerabilities in it. Priority of those, right? That's where that kind of comes into play as well. How do we actually go about addressing? I need to make sure my business keeps running, but I also need to make sure that I'm not causing, right, this type of vulnerability, this type of security risk. And that's really what it comes down to. So the reason this is becoming more and more prevalent, if you've got things like O-days that come up, you've got things like new libraries that are being used, because why recreate the wheel? Somebody already built this functionality, I'm just going to use it, right? Scenario. And then you also have custom code that comes into play. A lot of those vulnerability scanners that are out there are going through and they're looking for known third-party vulnerabilities. Well, half of my code is my code. It's not external vulnerabilities. How do we track for vulnerabilities there? That's a really easy place for things to leak in as well. We also run into scenarios of different silos. Jason was mentioning we've got the business that needs to keep going, right? We've got the development team who wants to build really cool stuff. We've got the security team who's trying to say, hey guys, slow down a minute, I need to read this, right? And then we've got the operations team who's just trying to keep the lights on. And what happens is those different groups, those different silos, they are all so focused on their goal, they don't talk to each other. And we don't have that context between them. And that's really what everything comes down to, is just making sure that these teams have the ability to be able to talk to each other, right? To be able to get that same information and get in line with the same priorities. Do we need to scan before we push to production? Yes. Yes, we do. But we need to make sure it's in a way, right, that's effective, that's not slowing down our business. Do we need to fix every single vulnerability? It would be nice in a perfect world. Can we afford to do that as a business? Probably not. Right? So what is our priority for that? And if you ask the developer and you ask the security team, their priorities are going to be opposite, I guarantee it. Right? So those are things we really want to make sure, right, we're keeping an eye on. Another thing that we're running into, especially with cloud-native applications, is the security tools that are out there today were not built for cloud-native applications. They were built for applications that took much longer in the development cycle, where doing a scan every 3 months, every couple weeks, was probably okay. That's not the case anymore. The tooling is not at a level, right, if you rely on just one set of tools to be able to do that. So we really need to adapt how we think about our software lifecycle, right? How do we actually break that out? What does that look like? So traditionally speaking, all of the security pieces, right, if you want to stop it from getting to production, if that's the CISO's goal, you focus on the left side. You focus on, right, when we're coding, we're doing scans, we're doing testing, right? Now it's in production. Okay, well, we did all those scans, we're good. How many people remember Log4Shell? Right? How long was that in production? Longer than I worked for Dynatrace, right? These are the kind of things that they come up, right? And this is the scenario that we need to make sure we're paying attention to. So we can't rely on the left side of the screen anymore. We've got to make sure we're looking at it across the board. We've got to make sure we're looking at it on the production side as well as part of that continual cycle. We're not going to give up the scanning, right, in pre-prod. That needs to happen. But we need to make sure we're paying attention across the board. So again, coming back to just an overall security standpoint, right, I keep pushing the wrong button. But coming back to, right, from a Kubernetes standpoint, there's a couple levels that you want to look at this from a security standpoint. So one of which is kind of that application development cycle and what that looks like, and we'll talk about that a little bit. But it's also really just focusing on what are the things that you can control. Because sometimes these are outside of observability or what we would think of as traditional observability practices. In my mind, they should be part of it. But in a lot of cases, there's scenarios where just setting up the environment, right, setting out apps, getting things deployed, those are things that we can control, and we can set controls around. But there's also those unknowns. There's that vulnerability that's been sitting out there for years that nobody knew about, that we need to make sure we're paying attention to. So when we think about things that we can control, right, one of the things that we can control from a Kubernetes administration standpoint is first and by far access. This is user access, this is application access, this is pod, this is service access, right? When you're looking at this, there's a lot up here on the view, and you can kind of take a look at that, but what it ultimately comes down to is, right, enable this least privilege. Start from nothing and grant up as you go. Mm-hmm. It's not a Okay, you get all the privileges, and then eventually maybe I'll take some away, right? Start from a security mindset when you start this process, because it's really, really easy to start building out these environments, because they're really easy to spin up. Right? I can spin up an EKS cluster in less than 5 minutes. And it's there and it's ready. It's open to the internet, which is probably not a great thing. But it's there. I can do whatever I want with it. I can put my applications on it. Yep. You got to think about this when you're building out these individual pieces. You have to make sure you're looking at this, right, from a secure perspective. Not just a performance perspective, not just a usability perspective, but from a secure perspective as well. Right, start with that least privilege. Now, flipping to the other side, right, now I'm up and running. Right, I've only granted the applications the access that they need. Now I'm up and running. What's going on? This is where we can start taking that observability data that we've been talking about, that traditionally speaking we look at from a performance standpoint, right? From an up-down standpoint. We can use this for security too. It's already there. There's nothing extra we need to do. We have the data. Now what we can actually do is we can start using this, things like threat hunting. We can use this for incident response. We can go back and actually query and audit. This person, access was removed 2 months ago. Why did they log in yesterday? Those are the kind of things we can actually be able to go through and pull in. At the same time, we want to make sure, right, we can look at this across the cluster perspective. So it's application level, and it's also right, at the cluster level.
And because like sorry if I'm taking your thunder, because distributed tracing, like you're seeing what requests are being made and like who's making those requests and all of that, it's super helpful for threat hunting and incident responses because you actually have a proven record like, hey, this exactly happened. And same thing with log data, right? Great to use for that threat hunting. And one use case we actually had was on an e-com website. They suspected somebody was doing credit card fraud through it, and we could go through and see the same user over and over and over and over and over again trying different credit card numbers. So it's kind of a simple use case, but like pretty cool to then go, hey, we're seeing all these credit card transactions. Like, you can't screw up your credit card 20 times in a row, 100 times in a row, 1,000 times in a row, you know? So.
Yeah, and cool. That's really what it is you have that distributed tracing information. You have the observability information. Right? Having the data is the first step. Right? Then it's about pulling in AI to do that analysis. Then it's about going through and doing those analytics. Yep. Hey, there's this new use case we have. Can we do something with it? That's where we want to go with that. And in fact, that's exactly what happened here. Is we were actually working with a group. We were already capturing transaction distributed trace information, and the MOVE It vulnerability came out, right? Or was released or published. And now all of a sudden, everybody's got this software sitting in the background, hiding in a back room, moving files around, but it's really critical to the business. We were actually able to go through, take that distributed trace information, and identify when that vulnerability was getting triggered, when people were doing that injection. If you have the data, you can get down to it. Right? And that's what it really comes down to, is making sure you have that information and you have tools in place that allow you to do that analysis, that allow you to go through and break that down. Not only for post-analysis, but also, let's think about stopping it before it happens. Let's think about identifying those scenarios. So we go back to, I talk about Log4Shell. That came out of nowhere. Using tools that have things like distributed traces information, that are doing things like tracking the libraries at runtime, allow us to be able to go through and capture those details. Because keep in mind, traditionally speaking, when we think security, we think scan before we release. Right? Are you running vulnerable libraries? Yes or no? And what's the risk of those? But when you have something like this that comes out, and you have something like that that's spread throughout your entire organization, and nobody knows how many servers or which ones are touching the internet, those are key important pieces to be able to track. So we need to make sure we're doing that and we're tracking it from a runtime perspective as well.
Because a lot of the times, like when you're seeing the number of vulnerabilities, you get this massive sheet, and you're like, well, what do I focus on first, right? I've got this massive list of vulnerabilities, but if you're looking at it from a runtime perspective, and you're looking at it in production, you have the context of how it's running, how it interacts with the rest of the environment, like, you can prioritize that stuff really, really efficiently. Because if it's talking to the outside internet, right, that's going to be a higher rank priority. Or if it's talking directly to a database, higher rank priority. If it's not touching all that stuff, right, and maybe it's a, medium on the CVSS score, like, maybe we can focus on that next week, right? Maybe we don't have to fix that today. So by having that context, it helps build that, prioritization, and ultimately, I think, helps improve, DevOps and security collaboration, because you're really fixing stuff before, right, it becomes an issue, and, focusing your efforts on what actually matters.
Yeah, and that's really what it comes down to, and you made a really good point there of kind of making security work with DevOps. Maybe it turns into DevSecOps, right? Maybe.
Yeah, maybe.
But it's also one of those things, it's about breaking down those silos, right? We come up with these acronyms of DevOps and DevSecOps, and it's about bringing those teams together and getting everybody on board, and sometimes that's just marketing. Right? But sometimes, if it's done well and it's done right, it's about bringing those teams together for that shared goal, about making sure that we are getting to that point. And that's really what this is about, is when we're looking at things like these vulnerabilities that may pop up, right? Again, how many of those get released to production? Is this a high priority or not? Right? Well, does it touch the internet? Does it touch my database? Right? Those are key pieces of extra context that can help that prioritization process so that everything is not a fire drill, so that you have the opportunity, right, to be able to internally within your business determine what are going to be our next steps and what that looks like. When we talk about runtime vulnerability tracking, we're not just talking about the applications themselves. Kubernetes is built on open source software. Right? It's out there. How many times does Kubernetes update a year? Right? These are things that are going to be introduced. We want to make sure we're tracking this. Not only, right, those updates, but also the configuration. We talked earlier about I can go in and spin up an EKA cluster super fast, right? But now, what do I have to configure on it? Right? Do I want to change my ports? Do I want to change, right, how many node pools are running? How do I want to actually lock this down? These are key pieces we want to make sure we're tracking as well. So we have to look at vulnerability and security not only from an application perspective, but also from the actual cluster itself, right? From the Kubernetes layer. And we want to make sure that we are providing that context. And again, the key piece behind this is not hiding the data. It's not giving it to one group and saying, go fix this. It's about making sure that the entire team, everybody is on the same page, and everybody knows what those priorities are. So if we have that data in context and we know this vulnerability is on this application, but it impacts all of these other apps, that's where we can start adding in, right, what are going to be the priorities that we're going to focus on from a business perspective, and where are we going to pull those in. And I'm going to say it one more time. We can't do this manually. We have to automate, okay? These same type of checks, even if it's running at runtime, even if it's running in production, we can still do these checks and make sure that these things are not happening. Not just for performance, not just for errors, but also those security pieces. This is not a point-in-time scan. Those scanners are never going away, right? We're always going to have those. But we need to make sure we're watching this across the board, right? As we're up and running, as the environment's up and running, we need to make sure we're tracking that. Using automation systems that can catch that, and then come back, not only tell our teams, but maybe put in some remediation. Maybe there's one server over here in the pool that we see the vulnerabilities on. We don't see it in the rest of the cluster. Maybe we cordon that node off. Everything else gets to keep running. The business gets to keep running. That's safe. Now we can send our team in to go fix that. That's what it's about. It's making sure we have that automation and that flexibility in place to be able to do that.
So yeah, so some key takeaways about everything that we covered today. So first, leverage observability data for understanding the performance of not just your application, but also the health and the resource utilization of your Kubernetes platform itself. Because observability data really becomes that foundation for optimizing your applications and ultimately, releasing more secure, more performant software faster, and improving user experience. What we can do is use AI on observability data to automatically detect problems and get us to precise root cause and reduce some of that complexity with all those different dependencies that we have within our environment. Then leverage SLOs to check the quality of our releases and our changes, make sure that we're not having new vulnerabilities or slow performing releases going into production, and using SLOs as that common language between everybody within our teams. And then kind of looking at that observability data with a security lens, right? Being able to do audit and forensics, find where we have vulnerabilities, the prioritization based on where they're running in production, are they talking to the internet, are they talking to databases, and really help foster that DevSecOps collaboration.
And again, thank you very much, guys. Really appreciate it.